Today I am going to explain verification of Beard's-Lambert's law, and the aim of the experiment is to determine copper concentration in the given sample by colorimetric method. In this experiment, to perform this experiment, I need two solutions. They are the copper sulfate solution. The strength of the solution is 1000 ppm, ammonia solution, and a device that is known as colorimeter is used for conduction of the experiment. The theory of the experiment, basically we are going to determine the copper ion concentration with the help of the Beard's-Lambert's law. And for that we know that every molecular species is capable of absorbing certain characteristic wavelength of electromagnetic radiation. When these radiations are passed through a sample of a compound, some of the frequencies are absorbed while some other frequencies they are transmitted through the sample without being absorbed. So if the percentage of absorbance or percentage of transmittance is plotted against frequency, we are able to get the absorption spectra. So for this experiment, the Lambert's law states that the rate of decrease in the intensity of the light with thickness of the medium is proportionate to the intensity of the incident light, which can be expressed as minus di upon dl, which is directly proportionate to I. According to Beard's law, it states that whenever a monochromatic light is passed through absorbing medium, there is a decrease in the intensity of transmitted light, which is directly proportionate to the intensity of the incident light as well as concentration of the medium, and it can be expressed in terms of minus di upon dl, which is directly proportionate to I dot C. And if we combine both the expression, I can express it in terms of log I naught upon I and minus log T, that is equal to epsilon ECl. It is actually equal to absorbance, and absorbance can also be expressed in terms of optical density. So the molar extinction coefficient is a fixed value, concentration is shown by the C, L is the thickness of the medium, OD is the optical density, A stands for absorbance, T stands for transmittance. So always remember that a molecule never absorbs 100% amount of energy. Only a part of energy is absorbed and remaining is transmitted back. Now if we look for the simplified diagram of the colorimeter, we can see that there is a source of electromagnetic radiation. So it is the incident light of the required wavelength is provided by the different sources for different spectroscopic techniques. So here there is a source, and number two, we have seen that there is a filter of monochromators are there. These monochromators or the filters, they convert the polychromatic radiation from source into narrow bands. That means it is going to convert in terms of monochromatic light. Then there is a sample holder, the sample holder which where we can insert the small cuvettes, the cuvettes which are containing the solution in it. And afterward there is a detection unit. The main function of any detector is to absorb the energy of photons and convert it into measurable quantity such as electric current or thermal changes. Generally, the detectors, they generate electrical signal, or we are able to record the readings. Afterwards, there is an amplification and recording unit. The main function of this amplifier is to amplify a signal so that it can be measured. So there is a small device which is used for the detection of absorbance is having this arrangement. Here the absorbance or the optical density, as I earlier told you, that A is equal to log I naught upon I, where I naught is the intensity of the incident light and I is the intensity of the transmitted light is represented. Now when we are going to perform the experiment, for that we need some solutions, and the solutions, they are having a varying concentration. We need a series of standard solutions. All these solutions are prepared in 50 ml standard flask, and for preparing these solutions we are going to use copper sulfate solution and ammonia solution. So and when the copper sulfate is going to react with ammonia, it is going to form a complex which is having a deep blue color, and it is tetraamine copper 2 sulfate complex. This particular complex is having an absorbance of 620, shows the absorbance at 620 nanometer. So we need a light which should have a wavelength of near about 620 nanometer. If more than the wavelength is given more than 620 nanometers or less than 620 nanometers, then we are not going to see any kind of excitation. The molecule will remain on the ground state. So once the solutions they are tested for their absorbance, after that those absorbance values are plotted against concentration to get the calibration curve, and a known volume of the test solution is also given to detect the concentration of the copper ions in that solution. Now in the procedure, the various solutions will be prepared. The total number of solutions will be prepared is 7. Out of 7, one is going to be a blank solution and another is going to be a test solution. Remaining 5 solutions where the concentration of copper is known to us. So the first we will prepare blank solution. We will take the 50 ml standard flask, and in that we are going to add only 5 ml of ammonia solution, and we will dilute it with double distilled water, make the solution up till 50 ml. So this is a blank solution which is used for the calibration of the instrument, and with the help of this blank solution we will calibrate our instrument at 0 absorbance. Then the next solution will be prepared with the help of 5 ml of copper sulfate solution, and 5 ml of ammonia will be added to it. You can see that there is an appearance of the dark blue color, and that dark blue color is because of the formation of complex. Once the 5 ml of copper sulfate and 5 ml of ammonia is added, then it is diluted with double distilled water and the volume is made up till 50 ml. Afterwards, we keep on increasing the concentration of copper sulfate like 15, 20 and 25. Ammonia will be in the same volume, that is 5 ml, and then all of them they will be diluted with double distilled water and the solutions will be made up to 50 ml volume. Once all these solutions, now we are having 6 solutions where the one is the blank solution, remaining 5 solutions are having a known concentration of copper, and the last solution is the test solution where the unknown quantity or unknown volume of copper sulfate will be given to you. In that unknown copper sulfate solution you are going to add 5 ml of ammonia, and then you will dilute it with distilled water and make the volume till 50 ml. So now we are having all the 7 solutions. Out of 7 solutions, one is the blank one for the calibration, and remaining 5 solutions were the known concentration, and the last solution is the test solutions. Close the lids of the flask, shake them well and keep it them. Now for conducting the experiment, we will set our instrument. We will, as it is shown in the video, in the demonstration video, that we have calibrated our colorimeter with the help of blank solution, and we have fixed the filter at the filter number 61. So with the help of fixing that filter 61, we have convert the light in terms of the monochromatic light. Afterwards, one by one solutions are kept in the sample chamber and tested for their absorbance. Once 5 ml solution, you might have remember, this is the observation table. When we are going to look for the absorbance, we have to fill this observation table. You must be remembering that we have taken the solutions where when the blank solution was there, we were having no copper sulfate solution over there. Ammonia was 5 and the absorbance was fixed at 0. Afterward, the 5 concentration, the solution which is containing 5 ml shows the absorbance at 0.09. Then 10 ml solution has shown the absorbance at 0.18. 15 shows 0.25. 20 shows 0.31. 25 shows absorbance at 0.39. And the test solution shown the absorbance at 0.15. Then this ml, the concentration of copper sulfate which was in ml has been converted in terms of ppm with the help of the formula N1V1 is equal to N2V2, where N1V1 is for the stock solution and N2V2 is for the standard solution. Stock solution was having a strength of 1000 ppm. Volume is a varying volume, that is 5, 10, 15, 20, 25. So we will keep one by one. N2 we have to calculate, and V2 is 50 ml because we have prepared the standard solution in 50 ml quantity. So when we will put the values, we were able to get the normality of this standard solution, and that is in terms of ppm. So you can see that 100, 200, 300, 400, 500 ppm is there. Afterwards, we need to plot a graph. The graph, it is known as a calibration curve. On the x-axis, we have taken copper ions, that is in ppm, concentration of the copper ions in the ppm. And on the y-axis, we have taken the absorbance at the lambda max of 620 nanometers. So for plotting a graph, we need to choose a suitable scale on the x-axis and the y-axis. And if you remember, I have shown that on the x-axis we have taken the this concentration 0, 50, 10 like so up till 500 ppm, and on the y-axis we have chosen a scale. According to that, we have taken 0.05 to 0.40. Afterwards, as the readings we have received at 100, 200, 300, 400, we have plotted all those points. Then we are going to join these points, but we will start our graph from the origin, and it is must for this calibration curve that it should pass through the origin. So we will start line from the 0, and then we will see that how many of the points they are lying on the graph. So you can see that the first point is almost nearby to the line, the second one is slightly far off, and remaining 3 are on the line only. Then we have to we can also plot the unknown test solution. We know that the absorbance we have received for the unknown solution was 0.15. So we have marked that point and extrapolated it till the line. We have marked that point, and again that mark has been extrapolated to the x-axis. So where this x-axis is going to cut this line is going to give me the concentration of the unknown test solution, and you can see that the unknown solution is having a strength of 190 ppm. So my results is the copper concentration in the test solution is 190 ppm. There are some precautions we need to follow for this experiment. The number 1, the standard flask, they should be properly rinsed with the distilled water before we are going to prepare the solutions. Number 2, the readings, they must be recorded after 10 minutes of the formation of the complex. And number 3, we need to clean the cuvettes with the help of the tissue papers. Also the cuvettes, they should be filled 3/4 only. Otherwise, if you are going to fill these cuvettes till the end of this cuvette, then there's a chances that the solution may spill out in the instrument, and it is going to spoil the instrument. So with this, my explanation for this experiment is finished. Thank you so much.